Welcome to an introduction to indirect proof. The goals are to define indirect proof and then provide two basic examples of indirect proof. So far our proofs have been direct proofs. The conclusion followed from a series of definitions and previous proven theorems. Indirect proof is a proof when we temporarily assume the conclusion is not true, and then we reach a contradiction to our assumption, therefore proving the conclusion is true. So here are the steps to an indirect proof. Step 1, again, we temporarily assume the conclusion is not true, and then we logically reason until we reach a contradiction, and then we finish by stating that the temporary assumption must be false, therefore the initial conclusion must be true. Let's take a look at a couple basic examples of indirect proof so we get a better feel for this type of proof. We'll first take a look at an indirect algebraic proof. We want to prove that if x equals 5, then 2x plus 4 cannot equal 12. So by following the steps of indirect proof, we'll start by assuming that the opposite is true, meaning if x equals 5, then 2x plus 4 is equal to 12. Now what we'll do is go ahead and solve this equation, and then hopefully reach a contradiction. Let's give it a try. So we're going to solve 2x plus 4 equals 12. So the first step would be to subtract 4 on both sides. So we'd have 2x equals 8, and this would be from the subtraction property of equality. The next step would be to divide both sides by 2. This gives us x equals 4, and this was the division property of equality. And x equals 4 contradicts our assumption that if x equals 5, 2x plus 4 equals 12. And this is the key to an indirect proof. Once we reach the contradiction, we can state that our assumption is false, therefore the original statement must be true. Let's go ahead and write this out. So x equals 4 contradicts that x equals 5. So as a result, our assumption is false. Therefore, 2x plus 4 cannot equal 12. And this is exactly what we were trying to prove from above. If x equals 5, then 2x plus 4 cannot equal 12. Let's take a look at another example. If triangle ABC is isosceles, then the base angles cannot equal 95 degrees. Again, we want to prove this statement by using an indirect proof, so we'll start by assuming the opposite. Well, the opposite would be that the measure of the base angles is 95 degrees. So let's see if we can contradict this statement. Well, if the base angles measure 95 degrees, the sum of the base angles would be 95 degrees plus 95 degrees, which is equal to 190 degrees. Remember, the base angles of an isosceles triangle are the angles that are opposite the congruent sides, those two angles there. By now we should know this is not possible because this contradicts the triangular sum theorem, which states the sum of the interior angles of a triangle is equal to 180 degrees. So if the sum of the interior angles is equal to 180 degrees and the sum of the base angles here is 190, this is all we need to prove the given statement because this is an obvious contradiction. Therefore, we can conclude that the sum of the base angles of an isosceles triangle cannot equal 95 degrees. And we have our indirect proof. So I know these examples are pretty basic, but hopefully it gives you an idea of the format of indirect proof. I hope you found this helpful.